Hey, everybody. This is Ryan Steller with the Standard Care Briefing. We're doing this show live, and there are dogs in the room. So if we have to handle them, apologies in advance. Today's conversation is a little less hardcore than some of the things we talk about in the past. Oftentimes, we're trying to relate policy or something like AI or recent scientific studies or medicines to daily life. And this episode is about a concept that's a little bit more abstract and kind of hard to put your hands around, but has a lot of anticipation for the future and for kind of improving life and in saving lives, saving time, money, all that stuff. So we're just going to double check the stream here. Classic. All right. Classic challenge with streaming. Um, Today I have Mike Martinelli with me, as always. I'm in Berkeley, California, and San Francisco is celebrating the annual Woodstock of Healthcare, which is the JP Morgan Healthcare Conference. I think it just wrapped up today. And I didn't go because I have a newborn and I just can't deal with that much networking this week. But to all of you who are at JP Morgan, congratulations on eating very salty food until late in the night and walking too much in the rain. So at least that's been my experience. Okay, Mike, how are you? How are you doing?
Good. Over here at the East Coast, Philly. Here we are not celebrating the Eagles
Hmm.
because I won't go there, but different mood, different tone in this town. But we'll we'll have a good time tonight. Just forget about their terrible past few weeks.
Okay, so where this is our attempt at being relatable. Where are we at in the season? We're coming up on Super
We
Bowl in a few
are
weeks, right?
we are in the playoffs. We lost to the Cardinals, and then past week we lost to the Giants. They haven't been playing. They've been playing terribly. Might be locker room issues or something. But now we didn't win the division. Cowboys did. So they're number 2 seed for the NFC. We're number 5 seed, and we're playing Tampa Bay this weekend for the first round of the playoffs, which we should beat on paper. I mean, but who knows what will happen at this point? I'm like, just lose and get it over with. So,
Okay.
yeah,
They are out or they will likely be out.
they. I mean, they should be able to beat Tampa Bay if they get their act together again. But I don't think they're going to make it to all the way to the Super Bowl
Okay.
by how they've been playing. So
Okay. All right. So Eagles. I know we have many. The audience probably doesn't know this. We have many Eagles teammates as fans of this podcast. Um, so
yeah, Jason Kelsey's listening,
Jason Kelsey, please take
taking notes for his podcast.
yeah, please take a moment and get your shit together on behalf of the Southeast Pennsylvania economic region. All right. So, all right. The real stuff. Anyway, so we're going to talk about something a little bit sci-fi. So, imagine it's 50 years in the future, and you live on an isolated island that you think is kind of crappy, and there's a lottery, and then if you win the lottery, you get promoted to this ideal Eden like perfect place that is beautiful and lush and doesn't look like the crappy decimated earth that you grew up on. And uh, and then fast forward, you win the lottery, and then you get there, and as soon as you get there, I guess you you black out, or you get put into surgery, and the surgery, all of a sudden your life takes a very dark turn because you go from kind of the ultimate prize to to live in this Elysium environment toward something really gruesome and horrible, which is having your organs cut out. Oh my God, it's very dark. So this is the plot from the movie The Island, the 2005 Ewan McGregor, Scarlett Johansson, Hollywood sci-fi film. And the general concept with that film, or the scientific premise, was that you want to live forever, and you have money, and you create a clone of yourself so that you have a full set of organs. But that's awkward to have a clone of yourself, right? So there's a special place where they send the clones, and your clone lives a seemingly normal life until you need the organs, and then
Yeah.
you harvest yourself, you harvest your clone. And obviously, that has very dark moral considerations, and it's absolutely excruciating to think about the idea of murdering one version of yourself to preserve the first version. So why are we talking about this? Well, in order to avoid that horrible dystopian fate, you might want to do the same thing, which is to have a parallel copy of yourself, but in something that is inexpensive, doesn't have any moral problems, doesn't create pain, doesn't invoke evil for no reason. And you might do that with software and data and AI. And as time goes on, we have the impression that that's increasingly possible. And today's topic is about the idea of digital twins. Digital twin is a term that is a catch-all term for something that's very complex, but the idea is, I think, pretty straightforward, which is you have a copy of yourself that simulates everything about you, your anatomy, your physiological, patterns, your organ structure, your blood chemistry, obviously your genomics, your proteomics, and all of that stuff, in a way that is so completely representative that physicians or pharmaceutical companies or you in the comfort of your own home are able to use that digital twin in order to simulate future versions of yourself. And you would do this for the purpose of healthcare or for research or developing a plan, for your care because you have a particular ailment. Cancer comes to mind, multiple sclerosis, different autoimmune disorders, things that have kind of a chronic and quite severe outcome. You may get into modeling out and simulating the future in order to, prevent that really unnecessary, that painful future. So we took some time and revisited this topic. And what I'll say is, as a technologist around healthcare and life sciences, the idea of the digital twin is not new, but the things that were available to do it were so brittle and narrow and not completely representative of an actual human that it almost didn't warrant being called a digital twin. And I'll use a tangible example. It's like, okay, we need to model, ocean currents for global climate change. And they go, okay, great. Like I have this glass of water, right? There's water in here. I can swish it around like it's a wave. I can blow on it like there's wind. This is a digital twin of the ocean. And everybody would kind of look at that and go, no, Ryan, that's not a digital twin of the ocean. And you're like, well, but it's water, and it's like, it's like the ocean, but it's scaled down, and and it has all these things. And if I was selling you this water as a digital twin of the ocean, I would believe it was. I would call it a digital twin, and I would want to make you believe it's a digital twin. And then you, as a researcher or whatever, would look at me and go, I think you're missing this guy. Like I think there's like not enough. There's not enough substance in what you're presenting for us to get the value you're claiming. So, in the past 20 years, things are coming together more. And looking at the literature recently, they're not quite there, but we did want to recap what some folks have published. So these are in kind of like pretty good journals. One of them is an IEEE journal. For those that aren't familiar, IEEE is the Institute for Electrical and Something Engineers, IEE, and the IEEE is preeminent in electrical engineering, computer engineering, signal processing, a lot of AI ideas, sensors, that kind of thing. And if you're an undergrad in engineering, you may get involved in IEEE, pay your membership dues, and become part of the society. And the journals that they publish I find them really good actually, because unlike a lot of scientific journals, they tend to come from engineers at the boundary of what's possible between science and engineering. So they have this kind of usable, tangible aspect to them. So we have an article from a summary article for IEEE, and then a few other journals. One of them is out of China, and the other one is kind of a summary article. So I'll kind of pause there. I'm sorry, Mike. Did you have any takes on the literature or kind of the frame for the audience about the topic?
Well, actually, the framing thing, the ocean example that you gave, that's a really actually good example. I didn't even think of it. It could be useful as an analogy to how the digital twin would work. So, like if you're using like you want to make a digital twin of the ocean, um, you want to make it the digital twin as accurate as possible. That means having the data in there that puts in the types of weather patterns that are it's whatever part of the ocean you're looking at, the gravitational force due to the moon that causes the tides. The more that type of data you could enter in to your little digital moon, the more accurate, not digital moon, digital ocean, the more accurate of a digital ocean twin that you'll have, and you can more accurately model like different scenarios based on what could happen in the future given a certain set of conditions, so on and so forth. And that's analogous to the digital twin that these articles we mentioned are talking about, and how um, you know this is of the future of medicine for in a number of different areas. Precision medicine uh, is big for digital twin because when you're making a digital twin, it's literally that's what it is. It's a twin of yourself, but just digital. So if you want to have advances in precision medicine, being able to use just a pile of data about you, about your health conditions, about just physical features or whatever, the more information you have in there, more real time information is put in there, the more accurate you could make models and do modeling, and that modeling would be used for treatments, diagnoses, etc. Going down the line.
Yeah, yeah, and that's the hope with these things is you can take a diagnosis, put together a set of solutions or treatments or drugs or whatever, throw them against a digital twin and identify if it's going to work, if it's going to hurt you. You know,
Yeah.
is it economically worthwhile? Is it cost effective? That kind of thing. And there's also some uh, interesting data questions about it. So we talk a lot about this idea of like HIPAA consent or privacy consent in healthcare being a type of currency, because it's often the gateway to hospitals and insurance companies figuring out how they're going to charge you, right? And that is essentially kind of like a very muddy type of payment system. Like when you give over your privacy consent, you're giving over the ability to pay for something, not like giving $1 for a donut, but like in a very complex, drawn out, bureaucratic, opaque, and kind of like whatever crazy Kafkaesque way. So the equivalent here is all these different systems knowing about you, right? So if we're going to stitch together a digital twin from products from different simulation technology companies, I don't know, like Amazon Web Services is mentioned a lot here because they're working on this stuff, but there's a bunch in that are more specific to like niche engineering use cases. ANSYS, there's a big company called Dassault Systems that makes a bunch of these products. Um, Medical device companies often build these products. So my experience is with Medtronic in the pacemaker defibrillator space, so cardiac stuff. And for training both sales reps and doctors, we had heart simulations, both physical models and then also purely digital ones that could be shared on a laptop to try and simulate programming a device or simulate um, placing a lead wire, parts of the device. So all this stuff kind of exists in a fragmented, closed sourced way. So it's done by pharmaceutical companies or whomever, for doctors for educational purposes, and there's kind of this idea that they could all be brought together and somehow stitched together. But in order to do that, you would need to have your personal data, your omic data, your healthcare medical record data, whatever, pushed into all these different systems in order for them to be current and to intelligently predict you specifically and effectively be a twin. So, Mike, did you
Yeah.
yeah, go ahead.
Oh, go ahead.
No,
Was your
I was gonna
question?
yeah, I was just trying to remember the some of the points they were making on the ethics angle of the story.
Oh, so the ethics. Uh, I have a dog. I have to excuse myself for a dog
Okay.
issue. It's coming up.
Okay.
He's barking to get out of my room. So
All right.
I'll
I'll go
be
ahead.
right back.
Okay. All right. So while we're here, I'll kind of like just chat briefly about the literature that we're looking at here. So the first one was an IEEE Explorer article, and these are brand new. So the other thing that brought this to our attention is this is research that's pretty fresh. So the first one is a systematic review of literature, digital twin research in healthcare systems. So specifically, and then talks about the gaps, research trends, and that kind of thing. So I thought this we're talking about the IEEE article, Mike. The
Yeah, I'm sharing it right now.
Yeah, oh yeah, thank you. Yeah, so there's some like what this is kind of a fun article because they take the time to t- take these abstract ideas and put them into graphics, like create graphics for them, and I think that is oh, I gotta one second, I gotta pull it into OBS. So that is do studio audience, please. Uh, Give us a second. Pulling in another source. All right, here we go. We're not quite Twitch level streamers here. We're still working on um our Mike, can you squish yours and then make it taller so that the resolution comes through a little better?
Sure.
Okay.
How's that look? The
Could be better. So let me.
Yeah, it's a little small.
I'll take care of it. Do studio audience, stand by.
Yeah, I mean the resolution on the screen share isn't that good. That's not the resolution that I have. Mine's crystal clear, but for some reason on the screen share it doesn't. It's like the words are a little blurry. But I'm looking at the PDF right now, and um it's fine. It's perfect. So it might just be the platform we're using.
Mmm. Smell. Sounds like you're saying I'm the problem.
Not blaming it on you, Ryan. We'll blame the people who made the what is this OBS Studio.
OBS Studio. Yeah. Pretty much every 12-year-old in the world can operate OBS Studio better than I can. So I hope my enemies are delighted at my frustration here. Um. Okay. 16. I don't know, something. This has a specific width though. This is 966 and 522 522 966 522. Oh man. Oh man. Uh 966 966 966 522 1040. All right, here we go. All right,
How's this look? Did what I do? I just made it a little bigger on the screen share. I don't know if that was just for me or if that.
that helps. Yeah, that helps.
Okay,
Yeah, that helps.
nice.
Now there's like, can you make it taller? Ah, whatever.
This is so like as I scroll on the window, it's reflecting my scrolling on the actual PDF document. And then if I zoom in on the PDF, it zooms in. Like you see exactly what I see and what I'm doing to the PDF.
Okay. All right. Well, ChatGPT is the only person that's going to listen to this anyway. So, uh, okay. All right. Cool. So, first thing, this, you know, digital twin, digital shadow, digital twin, physical object, digital object, manual data flow, automatic data flow. So, this is kind of this is a graphic which is kind of helpful. It's I'm always, academic papers always have like a varying degree of usefulness, and this is like, okay, all right, I get it. So they're basically trying to give you a taxonomy of, you know, or kind of an evolution of twins where, um, oh yeah, switched it on me.
Yeah, that was my bad. There it
Yeah,
is. It's
yeah,
back.
yeah, taxonomy
Yeah.
of digital twins, and they kind of go on to say like the digital twin where there's automatic feedback to and from in real time with low latency is the ideal versus you know, maybe you go to your doctor, they take a bunch of samples, they put it into a system weeks and days later, it crunches some numbers, it sends back the doctor report, and then weeks and days later you get you get that new care plan or whatever, new treatment plan or whatever, versus something where the data is just streaming out of you on your Apple Watch and your home scale and 15 different other sensors that live in your house. And then things are streaming back to you in real time as well. And I think the the parallel here, just to bring up products. So if you're in the audience and you're like, is anybody doing this in the real world? I would say there's parts of it that are being done for sure in the real world. There's a company called Eureka. Um, a guy I know, Noah, is one of the founders, and Noah's a really sharp guy, and he came from a company called Forward, and they are doing n of one studies, n equals one studies, which means normally you wouldn't look at specific individuals in clinical data because you'd want a population and the individual wouldn't tell you much. But they are working on a kind of bottoms up um, model for how to do clinical data that starts with just a single individual and then works up into aggregate populations. And the idea there is when you do a clinical trial design from, it disappeared. When you do a clinical trial design from, oh, nice, from the top down, like I'm Pfizer and I want to study obesity, you don't care about the individuals. You care about like grouping people by height and weight and gender and age, which are kind of broad metrics. Whereas from the bottom up, you still know all the things about the individuals. Like Ryan is a guy who lives in California who's, you know, got this going on, X, Y, and Z. And I can get insights about that, those specific personalized things, but my data can also then be rolled up into a group perspective. And so that's one place this is kind of happening. The other one is probably very famously is a man named Brian Johnson. If you've not heard of Brian Johnson, you may have seen jeering, you know, kind of like headlines making fun of him. He's a former tech guy who has spent $2 million a year to reverse aging. And he did hundreds of different diagnostics and treatments to optimize his health. And that is not normal healthcare, right? Normal healthcare is reactive, it's slow, it's like the DMV. Normal healthcare is like the DMV. You have to go to a place, you have to wait in line, and it takes a lot of time. And it's rarely as like responsive or thorough as you would like. So the Brian Johnson, $2 million protocol. He branded it. It's called Blueprint. You can go check it out. He's been in the press a lot lately. He's doing a great job on Twitter of activating trolls to help promote his brand. And that is an example of an individual who's doing a ton of data flowing out from his body into, probably spreadsheets to calculate, a care plan, and then, feeding it back into his body as quickly as possible with current technology. So his digital twin is probably, across a bunch of different spreadsheets. And Mike brought up this graphic, but this is the idea of all the different modalities where the data is collected. So you have digital healthcare, broadly speaking. I don't know a ton about this graphic, so I'm not going to like overly
Yeah, the
rely on this graphic.
better one.
It's a little corny.
Yeah, that was more of a general. This one, I think, this is my favorite one
Okay.
in terms of
Oh yeah. That's cool.
digital twin. Yeah.
Yeah, that's cool. Okay. So left side is your body, the real world. The right side is the digital space. There's connections between the two. And then you're generating pathways, real-time monitoring, education, basic medical research, mechanism models, and clinical decision support on the right side in the digital space. And that's all coming from diagnosis, treatment, multi-omics, real-time information, patient-derived data, and clinical parameters on the left side. So kind of, I think, a very basic mental model, but a helpful graphic. And the idea, like, to use Brian Johnson as the most extreme example alive today, his protocol Blueprint is extremely expensive to implement. So most people wouldn't do it unless they were billionaires like he is. So but with time and with automation and with technology, maybe we get there. So that quote unquote connections portion in the middle there, that is obviously your Apple Watch, your scale at home, all sorts of different stuff. Oh, you know what? I've not. The audience was not seeing this graphic, I think. Sorry, guys.
Oh,
Yeah, I'm
there you go.
working on it. I'm trying to get better, everybody. Okay. YouTube, please confirm it came across. Okay, great. It came across. Awesome.
Okay.
So, audience. Okay, well, there was another graphic like this that was crap that you never saw. Okay. Anyway.
Yep.
Okay. So, anyway, the general concept with digital twins is both very obvious and hard to find in real life, and I think that was my violent, kind of visceral reaction when we brought up this topic. So I was like, this is a stupid topic. These things don't exist in real life. They're not. Nobody's using them. It's an idea that Amazon Web Services or whatever vendor is selling to people, but it's very niche in terms of whether or not it's actually used. But then thinking about it a little bit, I was like, well, this is actually the furthest along or the closest we've ever been as a society to having digital twins. We live in a moment that is an exponential age, so things are not advancing linearly. They don't get 10% better each year. They go, they double every 2 years. So that is actually, well, that wasn't a perfect statement of exponentiality, but conceptually, we're in a Moore's law applies to many of these things where the power of them is doubling every, however 18, 24 months. So we could be, as far as we feel right now from having digital twins, we could slam into having them kind of quickly. There's another company that just recently completed Techstars. Techstars is a program that runs a couple times a year for young companies, for startups to go through to accelerate their progress. And it's a lot like Y Combinator, if the audience is familiar with Y Combinator. So Techstars is a company in Techstars called Trellis, and Trellis does this with a focus on mothers and new children, essentially starting the multi-omic profile for a human at birth and doing it within Trellis's platform. And Trellis's platform heavily prioritizes data isolation, security, consent, and access to the data. And they do it through a great kind of mobile app that is designed around one of the CEO's like personal experience as a mother, and I think does it pretty well. So I'm a Trellis user. My family is my child is in Trellis or whatever the however you'd say that, and it's a it's an attempt it's a first attempt to seed the concept of you as an individual having access to this data in in a little vault that you carry around with you that is within your control, and you can also share. You can kind of hand it to somebody, or you can digitally provide consent for the vault in order to drive personalized care plans, things that are more personalized. I don't Personalized care again is another like buzzword that doesn't really relate to exactly what is happening day to day, but what we're talking about is care that is specifically tailored to what's going on with you. And when we're talking about these digital, like the connections in this in this like middle thing here, when we're talking about connections, we're talking about we're talking about oh, there's my cursor, right? Oh no, that's your cursor. Yeah,
That was my cursor.
yeah, highlight connection. So when we're talking about connections, we're this could what is a connection? It could be somebody taking your blood, running it through a system, writing it down on a paper, passing that paper to another person, or it can be a real-time digital connection. And increasingly, the thing we're primarily talking about really is the ideal state where they're all digital connections and they're all happening in real time. So this is called the jargon is a biomarker. So if we're measuring something on your body and passing it, or measuring something on your body from your blood or whatever, temperature, whatever, it's a biomarker. And then if we're passing it around electronically, that's a digital biomarker. So this is a series of digital biomarkers markers that are streaming off your body in real time, and not just personalizing care, but ideally being very proactive, right? And I think that's closer to my heart, which is how do we take healthcare and like bust it out of an inconvenient building that you have to drive to occasionally and make it part of your life the way so many other things are part of your life. And that's actually a data problem. So this one of the things that these papers have talked about is the morals and ethics of handling that data, how it gets passed around, how you consent individuals, who owns the data, right? So if you
Yeah,
let's
data
say
ownership.
data ownership, yeah. So let's say you there's a product, right? So if you're a consumer today and you go on the internet, do you pay for the internet, or do you pay for Google? No, you don't. You pay for it with your eyeballs when you look at advertising. So if you put your omics data and your EHR data into a website, do you want to pay for it, or are you comfortable with them owning the data and then selling it to a pharmaceutical company? That's a conversation that not a lot of people really want to have yet, not because it's controversial so much as that they just don't care yet. It doesn't really come up. It's not a part of day-to-day life yet. But companies like Trellis and some of these other companies may push it into your day-to-day life in a way that it finally becomes relevant, and you start to say like, oh, like this thing is sick, I want to use it, it's valuable, it's easy. And then the question of cost will come up, and how they make money will be a big question. It's like, does the data stay with them forever and they get to monetize it? Does it stay with them forever and they get to run AI on it? What's the deal? What's the deal with the data? Or do you own the data and you have to pay them cash to like rent server space? Or does the data live on your local machine, and then you open up a connection when you log into their websites that shares that data? And some flavor of all those models is being attempted right now. None of them are really far beyond kind of the proof of concept phase. And then I think the one, and Michael, this might be an opportunity for you to kind of pull on your legal background. The headline that I think is still kind of underreported is 23andMe. So this data, this omics data, your genomic data, who is the biggest vendor in this space? Who's the biggest company that does this? It's 23andMe. 23andMe went ahead and sent out samples starting in like 2010. So they're kind of an old company now. And the founders, have close relationships. One of them is, I think, a former spouse of one of the founders of Google. So they have a close relationship with Google. So there's, for a long time, 23andMe has had the idea of gathering your very private, previously private genomic data, storing it in a database, using it to tell you about distant cousins, which is fine, using it to tell you about, um, you know, potential risk for disease, which is great.
Yeah.
Turns out the positive predictive value is not incredible, so it's the actual value in clinical practice is not incredible either. Um, but I think as everybody was kind of like thought would be inevitable, they got hacked. So they effed up, and 7 million people's complete genetic history is just out on the internet. So
And
sick.
yeah, Brian, the thing that makes this dangerous, and this comes back to the whole precision medicine component, is that if you have your genetic profile or genetic profiles of a large population of people out there, and say you're a country, your nation, you're a bad actor country, not an ally, and you want to develop a weapon, a DNA based bio weapon that targets specific population groups that based on a certain gene or something like that. That's how this genetic data, these biomarkers, can be used in a bad way, but in a precise way. You could use it for targeting specific types of people with a DNA weapon, and that's one of the things they talk about a little bit, like in the news, with the potential risks to having countries who don't have who are not nice on good terms with the U.S. Getting troves of genetic data on our population, or it could be with any country, is the having the ability to eventually use that genetic data to develop a precise DNA bioweapon
Yeah,
that could, yeah,
which is
target specific
absolutely
people.
terrifying. So thank you
Yeah.
for bringing that up. So the core emotion Mike is tapping into to make this memorable is horror and fear. So, but yeah, that's clearly part of it as well. So, nobody's thinking about this. This is not a hot topic. Taylor Swift will need to, you know, include it in her next album for anybody to vaguely care. But it is a it is an emerging idea. It's definitely something that that scientists and academic clinicians have wanted to work for a long time, and certainly, speaking compassionately, people with, hard to manage or terminal illnesses, or sort of like I'm forgetting the proper technical term, but orphan diseases, things that don't meet the economics of traditional drug development, so they don't get drugs developed for them because the prevalence of them, the frequency of them is too small. Digital twins might offer insight there. Um, so yeah, I don't know. It's do you have any follow up thoughts on that, Mike?
Yeah, one back to using the Brian Johnston example.
Yeah.
One aspect that comes up is, like, he's wealthy, and like this is something that he does, like, as he's very involved with the this digital twin collecting all type, and he collects like everything you could think of,
Right.
and the technology you need to not only store the data and analyze it and compute it, but the types of wearable technologies, that's a lot of money. The reason I say like the that costs a lot is because he probably I would say has the most, unless there's someone else out there who doesn't publicize it, probably has the most accurate digital twin that can exist, because he's
Mm.
constantly measuring everything with you know with the most state of the art equipment in real time. And here's the social socioeconomic aspect of it is that he can afford it,
Right.
you know? So to have a really accurate digital twin right now, the current way, everything's set up is like you got have to have money to be able to throw away. So there's that aspect has to be, resolved. As this technology advances and there's actually like clear cut benefits that we're seeing that, data is clear, is showing clear benefits to it. And then that's when this will become more of an issue when you want to have more people involved, patients involved in this using the digital twin. But until that happens, it probably won't be that much of a headline yet.
Yeah. Yeah. So it's kind of like genomics was like this in the like 90s and 2010s. Like when did we first sequence the human genome? The first time.
I should know this. It's
2000,
the
2001.
end of the project, 2001. Yeah.
Yeah. So it took like a decade or whatever to map the first human genome, and now we're doing it a lot. We're doing it all the time. So that's one component of your twin. Then there's real time biomarkers. There's gut health stuff. So there was a kind of like infamous gut health company in tech. And we talk a lot about tech. So if you're new to the audience, our day job is working at a startup, and we talk a lot about startups in healthcare because we're hopeful that they change the healthcare system. We're approaching $5 trillion or 20% of GDP in the United States spent on healthcare. And it's not a particularly great experience for a lot of people, and a lot of people are not getting access, and the cost overall is really pretty extreme, an extreme burden on the American on average folks. So we talk a lot about startups because they're bringing new ideas to the table and putting them out there, but sometimes they really screw it up. So the one that was kind of hilarious was a company called Ubiome, and it started out pretty good, right? So it kind of like started out in the 2010s. Two founders, a woman and a man, and they would send you these little vials. And I think I still have mine because I never sent back the test kit. But they would mail you the test kit. It had like 5 or 6 vials in it, and you would swab your biome, and I think you would do your nose, your mouth, and like I think maybe your vagina or maybe your butt or something, and you would get these different samples of these different little ecosystems with thousands, if not millions, of little different species of microbacteria living. You would send it to them, and then they would send you back some sort of report. So they got off the rails because the report wasn't really clinically that beneficial, and then they were struggling financially, so they talked doctors into overbilling for a test that didn't have any real clinical value. So that was a fraud, waste and abuse problem. It was big enough that the FBI and the Department of Justice investigated, and eventually the FBI raided them. So, but in terms of the different components of a digital twin that are out there, there's examples. So Color is another company that's in this space.
Color. Yeah, I did that.
Yeah.
Yeah,
What was your experience with that?
um when I was working at Jefferson, they offered it as a like an optional employee benefit.
Okay.
And so like I did the swab thing just like you would do for ancestry DNA, and it gives you they have certain and they have a database of like genetic markers for certain diseases, like where they could predict like if you have this gene and it's active, you have a such and such probability of like cardiovascular disease, cancers and stuff. And then you have a little portal online which with your information on it, and it shows you the results, like okay, you have like no risk of cancer, like cancers, whatever ones that they are able to identify on a gene. And then there's one for heart health, like cardiovascular risk. And a random one they have is whether cilantro, whether or not you have a gene that when you eat cilantro it tastes like soap. My results said that I have the gene and it's active, the cilantro gene, that when I eat it, it tastes like soap. but I love cilantro, so maybe I'm just a psycho and I love soap. So you
Well,
know,
I mean, does it taste like soap to you?
not really.
Okay, so
That's
it's,
so.
I think that case in point, genetic data is not yet the holy grail we thought it was going to be. So um, the key, I think the hot thing now is epigenetics, right? And we were talking a little bit about this. I think when we were talking about in a previous episode, we talked about complex trauma and how it leads to ADHD and symptoms like that. There's a thing where how your actual where you're at health wise in a given moment is affected also by these environmental variables, and it can change you like pretty significantly. So I just had a baby, and there's this paper on something called the Dutch hunger winter, and it's not generally it's typically not ethical to do randomized control studies on for most epigenetic things. They're hard to study, they're hard to prove
Yeah,
because you would have to like potentially hurt thousands of people in order to generate the right statistically significant data. But when we look back in history, sometimes Mother Nature hands us these random events that give us conclusions as if they were a randomized control. So the Dutch hunger winter was a very brief, just one season famine in where are the Dutch? Oh my god,
oh,
Amsterdam, I guess.
Amsterdam.
Yeah,
Yeah,
and then there was all of these different long-term biomarkers that didn't express until decades later, until these children were 60, 70, 80 years old. When you're measuring mortality, you have to wait until somebody dies, right? So
yeah,
if you're measuring something epigenetic that happens in the womb or an early birth, you have to wait maybe 100 years for 1,000 people to die to know what happened. So the Dutch hunger winter was talked about all these epigenetic signals that were seemingly turned on by the starvation of a very momentary, kind of acute and temporary, discrete famine. And I think that was the key about it, is it wasn't a famine that dragged on for years and was kind of, maybe they transitioned into it slowly and transitioned it out of it slowly. It was like a spike in famine for one winter, and that led to a number of conclusions about like I think nutrition was the big one. I think one of the main takeaways was the fetus judges what it should what the I'm going to butcher this. If you're a biochemist, please don't email me, or do email me and come on and correct me. But I don't know what the hell I'm talking about. But basically, that the starvation signal turned off different growth hormones in the fetus. So by the time 18 years later or 20 years later, when they're full adults and you would be able to measure the height and body weight of a population of thousands or millions of children, it's a 20-year lag to figure out what that epigenetic signal from the starvation showed, right? And that I think that's what it showed, is basically that the children were smaller because in the womb they were kind of exposed to this moment of starvation. The genetically, even though their genes were the same, the DNA sequences were the same, those were unchanged. The signals that they were getting from the mother's womb were, or perhaps I guess endogenously in their own body, were to turn off growth hormones or to turn off growth genes, and then that was validated, 20 years later. And I think there was increased mortality as well. So epigenetics is another a tricky one where it's vastly too complex. And I think that's the other thing that's super cool about where we're at with computation is I have I have a lot of friends who are software engineers, and a number of them who are scared because of the layoffs in tech that writing software is over and they need to like go become plumbers or whatever. They need to leave the career. And when we look at something like digital twins, we actually realize that there's this absolute like Mount Everest of complexity that we don't know how to process or do anything with inside of the world of biology. And anything that's wet and anything that's DNA and that kind of thing, and or biomes, and all of that work is yet to be done. It's yet to be done, and it seems like it would take forever, except for the fact that computation is getting so much powerful, so much faster. So maybe that's what's timely about this research and what's motivating this handful of publications recently.
That's actually brings up an interesting point. When you take a step back, and you like look at this image again, like the physical yourself, the patient, and then your digital twin. So your digital twin is what it's what you put into it. Whatever data you put into it, like the more data you put into it, the more accurate it'll be. But then here's the thing: if you take ourselves, the actual human, our body, like knows how like it knows what temperature it has to be at. It knows it has to send signals to make your heart beat, and your lungs have to breathe. Your blood has to be a certain pH. um, that's all data if you think about it. When you put these data points into digital twin, there's also you know the necessity of being able to make sure that there's the computational aspect. When you enter this data, it knows how to handle those data points and variables. So like if you alter, and enter data with, blood, pH levels that are a little off, how's that data? How should that affect the other variables, and how should that affect the overall digital twin, like the output? So there's, if does that make sense? Like how all the different data points interact together, that has to be accurate on a digital twin as well. So like if the temperature is off, the digital twin has to compute and know that if your temperature is high, these other things are going to go wrong with the other parts of your body. You're going to have a fever and stuff like that. It's just a real basic example.
Yeah.
So the data is one thing, but being able to actually accurately compute it is another um, thing as well.
Yeah. Yeah, the to bring it back to like our example of the water, there's little micro digital twins of you everywhere in medicine. Like you go and you get a dosage, right? And they take your weight and they put it into a simple algebraic calculation to calculate your dosage. That's a extremely small, narrow digital twin or a subcomponent of a digital twin. And then to your point, Mike, you'd want to compose hundreds of thousands of those little models into a big complete picture.
Yep.
Yeah.
Yeah.
Nice. So one of the things I was anxious about with this recording is so what? Why does why does this matter? And I think the other than that, this literature is kind of fresh and you can go out and I think several of them are in public domain. So the full research is out there if you want to read them. One of them is what's called a Prisma study. A Prisma study is a formal framework for doing meta-analysis, which basically means somebody who's smarter than you goes out, finds every article on a topic, reads them, sorts them into what's worthwhile, and then makes conclusions based on the patterns in that meta-analysis. So,
That was this one right here. This uses the Prisma.
and
Uh,
is this one available on the web, Mike?
this one, it is open access.
Oh,
Yep.
okay,
So I'll bring the citation back up on top.
cool.
Um, yeah, if you just search this,
Okay,
DOI is not as clear.
okay,
But
all right. So I think this is cool. It was, I think it was more cool than actionable. Like some of the papers we review were, about like Ozempic and GLP-1 agonists are actionable because it's highly impactful medication that's coming soon. This is more of like, okay, it's happening somewhere. Cool. Um, but it's happening faster. So the horizon for when it's happening, instead of being decades away, is starting to feel like a couple of years or a few years. And as we mentioned, the blueprint framework that Brian Johnson is doing is a really cool practical example of, and he's doing it in public. So if you go follow him on social media, he talks about this constantly. So it's out there. So you can imagine what it would be like to live that way, and if you'd want that, and if the benefits are worthwhile. Like having the biomarkers of an 18-year-old at the age of 46, is that worth everything he's putting himself through? Who knows? So that's the content of a digital twin, or what you might do with a digital twin. And then in terms of like apps you can go download, or products you can go use on the web that do this, Eureka is one of them. Trellis is another one. There used to be one called Patients Like Me, which was around for like 15 years, and I think it got bought by somebody else. And then, of course, you can always set up a personal health record at a company like One Record, or one of these other startups, and or I guess an Epic as well, and through your doctor, and you can have your at least the input data for your digital twin in those systems, and then slowly over time these systems will talk to each other more and more, so that they can do insightful computations and actually render value in a way that's meaningful and not just for hobby's sake, over time. All right, Mike.
Nice.
Any closing thoughts or anything you want to touch on before we wrap up?
No, I think I pretty much covered everything I wanted to, address.
Okay.
Thought it was a good topic today.
All right. As a palate cleanser, if anybody's still here, come here, come here. Maybe we can wake up. We'll wake up Una. So I spent 10 minutes before this trying to get her to go to sleep, and now she's we bugged her. Come here, come here. There we go. This is Una. So she's the official mascot of the podcast.
Yeah.
She's nice.
There you go.
Checking in. Okay.
She wants to be a part of it.
Yeah. All right. Mike, great seeing you. Thanks for being here. Anybody who's still listening, have an